Imagine stepping outside and watching the entire sky disappear. No blue, no clouds, no wind, no sound traveling through the air. Above you is a perfectly black sky, even in the middle of the day, with stars visible beside the sun. Now imagine that this is not a temporary disaster. Earth has completely lost its atmosphere. In this scenario, Earth's gravity, oceans, land, rotation, orbit, and sunlight all remain the same. The only thing changing is the atmosphere. Nitrogen, oxygen, carbon dioxide, water vapor, and every other gas surrounding the planet are suddenly gone. The first consequence happens in less than a second. At sea level, Earth's atmosphere pushes down with a pressure of about 101,000 pascals. That is roughly the weight of a small car pressing on every square meter of your body. Remove the air, and that pressure vanishes instantly. You would not explode like a balloon, but the water in your tissues would begin to vaporize. This is called ebullition. Body fluids exposed to the low pressure would start boiling at human body temperature, causing swelling and severe injury. You would probably lose consciousness in around 10 to 15 seconds, not because the blood instantly boils away, but because your brain runs out of usable oxygen. If you somehow reached a pressurized shelter within a minute or two, survival might still be possible. Without one, the planet's human population would be gone very quickly, and there would be no dramatic sound announcing the disaster. Sound is a vibration moving through matter. With no air, voices, explosions, thunder, and engines could not reach your ears. A bomb might flash nearby, but in the vacuum its blast would not produce the familiar boom. You would see the ground shake or feel vibrations through a surface, but space itself would be silent. The sky would also change immediately. Earth looks blue because air molecules scatter blue sunlight in every direction. Without those molecules, the sky becomes black. The sun would appear as an intensely bright disk, surrounded by darkness, while the stars remained visible during the day. But the sunlight itself would not become weaker. The atmosphere normally filters some ultraviolet radiation and burns up many small meteoroids. Without it, the surface would receive far more ultraviolet light, and tiny space rocks would strike the ground instead of producing harmless streaks of light in the sky. The next crisis would be pressure and water. At normal atmospheric pressure, water can remain liquid across a wide range of temperatures. In a vacuum, liquid water is unstable. It begins to boil even if it is cold, because boiling depends on pressure as well as temperature. So the oceans would not instantly vanish into space. Their surfaces would begin boiling violently, producing water vapor. But evaporation requires energy, and that energy would come from the water itself. As the surface loses heat, it would rapidly cool and freeze. The result would be a strange battle between boiling and freezing. The top layers of the oceans could turn to ice, while water below continues escaping through cracks and open areas. Over time, much of the exposed surface would become frozen, while some water would remain trapped beneath the ice. Earth's oceans contain enough water to cover the planet in a global layer about 2.7 kilometers deep if the land were perfectly flat. Losing the atmosphere would not remove all of that water instantly. Much of it would freeze into thick ice, and some would migrate into the ground or remain underground, protected by pressure and geothermal heat. But the surface would become almost completely hostile to life. Plants need carbon dioxide, and photosynthesis would stop almost immediately. Forests, grasslands, and crops would no longer be able to produce new energy from sunlight. Animals would continue using stored oxygen for a short time, but the food chain would collapse from its foundation upward. Microbes and organisms living deep underground would have a better chance. Some ecosystems around hydrothermal vents already depend on chemical energy rather than sunlight. In a world without air, those hidden communities might become some of the last surviving life on Earth. Temperature would become more complicated than simply everything freezes. The atmosphere currently acts like a blanket. It transports heat from the equator toward the poles, stores energy, and produces the greenhouse effect. Remove it, and the planet loses that thermal buffer. On the moon, which has almost no atmosphere, sunlight can heat the surface above 100 degrees Celsius, while nearby shadowed areas can fall hundreds of degrees below freezing. Earth would not behave exactly like the moon because it has oceans, soil, and geothermal heat, but its surface would develop the same basic extremes. The sunlit ground would become scorching hot, while areas in darkness would cool rapidly. There would be no air to carry warmth from one place to another. A rock exposed to sunlight could burn you, while a nearby shaded rock could be dangerously cold. The day-night cycle would become critical. Earth rotates once every 24 hours, so each location would still experience daylight and darkness. But without air, the surface would lose heat directly by infrared radiation during the night. Water and soil would moderate the changes, at least temporarily, but the familiar mild climate would be gone. Near the poles, ice would remain stable. Near the equator, surface conditions could swing between intense heating and rapid cooling. Eventually, the long-term average surface temperature would fall because Earth would no longer have an atmospheric greenhouse effect. The exact final temperature would vary by location, but the planet would be far colder and more extreme than it is today. The loss of air would also destroy the global water cycle. There would be no clouds, no rain, no snow falling from the sky, and no rivers fed by regular precipitation. Existing rivers would drain, freeze, or evaporate. Lakes would develop ice covers. Water vapor released from the oceans might freeze as frost or ice deposits on the coldest surfaces, gradually moving water away from warmer regions. The atmosphere also shields the surface from dangerous radiation. Without ozone, ultraviolet light from the sun would reach the ground with devastating intensity. Even organisms that survive the cold and lack of oxygen would need to live under soil, ice, rock, or water. Earth's magnetic field would still exist because it is generated mainly by motion in the planet's outer core, not by the atmosphere. But the magnetic field does not replace the atmosphere. It can deflect some charged particles from the solar wind, while the air normally absorbs and spreads much of the radiation and particle energy. With no atmosphere, the surface would be directly exposed to more of the space environment. Satellites would not suddenly fall from orbit. Their paths depend mainly on gravity and their velocity, not on the atmosphere. In fact, low satellites would experience less drag and could remain in orbit longer. On the ground, however, technology would fail almost everywhere. Combustion engines need oxygen. Gas turbines, cars, airplanes, and most power plants would stop. Wind turbines would become useless because there would be no wind. Solar panels could still receive sunlight, but the equipment connected to them would need cooling, protection from radiation, and people capable of maintaining it. Buildings would not be crushed by the missing pressure. They are designed to support their own weight, and many structures could remain standing. But anything relying on air pressure would change. Aircraft could not fly, parachutes would not work, and sealed containers might rupture outward if their interiors remained pressurized. Earth itself would not fly apart. The atmosphere is only a tiny fraction of the planet's mass, so removing it would barely affect Earth's gravity, rotation, or orbit. The planet would continue circling the sun, now as a silent, airless world with oceans locked beneath ice and a surface exposed directly to space. And that is the final perspective. An atmosphere can look invisible, almost empty, but that thin shell of gas controls pressure, temperature, weather, sound, radiation, fire, and the chemistry that feeds nearly every ecosystem on the surface. Earth is not made habitable by its rocks alone. It is made habitable by the delicate layer wrapped around them. Remove that layer, and the planet does not explode. It simply stops being the kind of world where life can live in the open.